start my recording. So how do I get my logarithm by itself?
Can you divide both sides by 3?
Mm-hmm. Okay, what do we think my next step is?
Convert to an exponential?
Yep, and how do I do that?
Wait, sorry, which one are you? Is it where the cursor is?
Yeah, right.
Okay, yeah.
Or you can do either of them. They're both the same.
Okay. So then you move the 2 to the other side and it becomes x equals 2 to the 3rd.
Perfect. So translating is one of the very first things we learn with logs. And so if you have a logarithm by itself, a number or even a variable on the other side, at that point, you're just translating, turning it into an exponential. So the x will stay the same. I've kind of just, the whole thing, I've undone the log, so I'll move that to the other side and get the x by itself. And so I have 2 to the 3rd is equal to 3, or 2 to the 3rd is equal to x. So what's 2 to the 3rd? Uh-oh.
8.
8. 2 times 2 is 4, times 2 is 8. And that's my final answer. And it never hurts to kind of check your answers in general. With logs, it's a little bit more work because we're not typically, I mean, maybe you are much better at intuition than I am, but it's usually hard to kind of plug that in and immediately say, okay, log base 2 of 8 is 3, so my answer works. But if you have a calculator, especially if you have a fancy calculator, honestly, it's not that difficult to plug it in and check. So why not? But a little bit harder if all you have is pen and pencil, or pen and paper, I think is the saying. Okay, that's my mouse. There we are. So exact same process here. I have a logarithm. I should probably get that logarithm by itself, and then I should solve. So I'll just run through this since it's not too terrible. If I want to get ln by itself, I will add 3 to both sides. I will divide by 5. Okay, so now that we got the first 2 steps out of the way, what do I do here? I should pop out the chat. Any ideas? Even if you don't know the specifics, there is kind of a step we did in even the previous problem that would be the next step. Class is always so quiet. I feel like it. Right? Go ahead, Austin.
Multiply ln to both sides.
It's not multiply, but we're going to
Divide, my bad.
translate. Yeah, so we're going to translate. So what is ln? What's this weird thing? What does that mean?
That's the natural log, but
So what's the base of the natural log?
E.
Yeah, exactly. So if I'm going to translate this, it's going to delete the whole thing. I'll be left with 2n minus 1, whatever is inside my log. It's not going to change because that's kind of the idea. I'm undoing this. And then I will have e to the 4th. Now, if I weren't in Mathland, if this was kind of an application problem, I would want to find what e to the 4th is. It's a decimal, but it's going to be a rounded decimal and it's going to be a little bit unwieldy. And so since we are in the math world, we typically like to have exact answers. So I'm not going to throw e to the fourth into my calculator. I'm going to leave it as is. And in my final answer, I will have an e to the fourth. So it's not going to look the nicest, but it will be exact as well. And the reason, or one of the reasons that we go for the exact answer in mathematics is we're solving these problems. We don't know who's going to use it. So if this was an engineering thing or maybe cutting a board, sure, a couple of decimal places being rounded is not the end of the world. But if this were something in chemistry, that becomes a little bit more important. Chemistry is very specific at times. So all that's to say, I'm not going to throw this into my calculator. But I'm still going to solve. I want to solve for n. So how do I do that?
Add 1 to both sides and then divide by 2.
Yep, just in the basic algebra at this point. So add 1 to both sides. Divide by 2. And voila. All of my ramble is to say that, or as an aside, that if you were to find the decimal answer on the exam, I get it. Sometimes you just don't remember all of the words exactly that I'm saying. I would still give you full credit. I would like you to certainly at least get to this point before doing any word calculator stuff. But at that point, if you did plug in e to the fourth, you got a decimal answer. I will account for it. But in general, it's a good habit to, if you're able to give an exact answer, you should. Okay. So now we're getting into this rhythm of, okay, if I have a single logarithm, goal is to get the logarithm by itself, translate, and then do a little bit of shuffling to solve. Okay. Now I have an issue here. I don't have a single logarithm. So how would I possibly be able to solve this equation, or how would I possibly be able to isolate a logarithm in this equation when I have 3? So does anyone have an idea? Granted, we haven't done a problem specifically like this, but I'm sure I did one in the video. Just gonna make a new slide. Does anyone have any ideas of how I might solve this problem?
Could you start off by rewriting the left side as the natural log of x minus 1 over x plus 6?
Yes, and so if we can compress our logs, we should. So yeah, exactly right. I have this, I'm subtracting 2 logs. So what do I do if I'm subtracting 2 logs? What's the rule? What do I do to the insides?
Technically made them divide.
Mm-hmm. Exactly. So then my problem will become this. And now, a healthy question to ask yourself in mathematics is the why. Why did I do that step? Yeah, it's cool to kind of compress things, but I also mentioned how sometimes we really like to tear them apart. Well, the reason that we made them into a single log is, well, just like when we were dealing with exponentials, and we learned that there's this kind of neat trick of, okay, if I have b to the x and I have b to the y, and both of those bases specifically are the same, just like they are here, well, then I have this nice shortcut of, well, the only way these two exponentials would possibly be equal to each other is if x is equal to y. So exact same shortcut, well, not exact same, similar shortcut here. If I have a single logarithm on the left side, a single logarithm on the right, and they're the same log, so they're both L in this case, then I can just drop the logs and I have a nicer equation that I could solve without knowing really anything about logs at that point. So since we've solved this before, and since I do want to give you guys a chance to review this, to solve this, I don't like having x in the denominator, so I will multiply both sides by x plus 6. I will then distribute my left side. I feel like my equation just keeps getting bigger and bigger. So x minus 1 equals 2x plus 12. I'm going to subtract x from both sides and subtract 12 from both sides. We'll get 2x minus x is just a single x. Negative 1 minus 12 is a negative 13. And there is my answer. Any questions about how I got there? Like I said, yeah, at this point I kind of speed ran the rest of the problem, but we've done almost the exact same problem when we're doing inverses. So this part of the problem has nothing to do with logarithms, so I just ran it. No questions. Now, something that I kind of got away with here that is generally okay if I'm able to do this neat shortcut and get a single logarithm by itself is that once I do that, then my answer is going to work, assuming I have done it correctly. But that's not always the case, and I should be doing what I'm going to do right now with a logarithm is I should always check my answer. So we're going to write that here in bold, just like when we were doing square roots, just like when we were doing rational functions. You need to check your answer. It's not an option. It's not, even if you do everything correctly, you still could be getting an answer that doesn't work. And then maybe you're thinking to yourself, oh, Zach's contradicting himself. He said, it's kind of hard to check my answer here, so why should I do it? Yeah, technically, we're not going to check our answer. We are going to make sure our answer works. Specifically, is our answer in our domain. So that's very similar to what we did with rational equations with, okay, we have a lot of fractions flying around, and sure, if you wanted to plug everything in and be good to go, that's not a bad way to check your answer. But it was a bit more work than needed, and all we really had to check to see was our answer in our domain. Austin, do you have a question?
Yeah, I was gonna ask, where do you for checking the answer, where do we plug it in at exactly? Will we the original equation, or could we plug in like the negative 13 into the original equation? Okay.
Yeah, that's always the idea, right? Because maybe hypothetically you made an error along the way, so you're not really checking your answer correctly if you plugged it in here. So anytime you're checking your answer, you should go as far back as possible. So we're going back to the beginning.
Okay, cool. Thank you.
Yep. And so let's check it. So we have x is equal to negative 13. We go to our first logarithm. We say, okay, what would happen if I plugged in negative 13? Okay, I would get negative 13 minus 1, so that would be negative 14. Is that okay? Am I allowed to have a negative inside a logarithm? Uh-oh. Okay, maybe I ask a step back of a question. What is the domain of a logarithm in general?
Wouldn't domain be somewhere inside the log parentheses, comma infinity?
Yes, specifically it has to be greater than 0. So if I was asked to find the domain of, honestly, this, my first step is to set the inside greater than 0. In order for me to find the domain of a logarithm, the inside value has to be bigger than 0, not greater than or equal to, specifically greater than 0. So here I have a negative ln, well, the negative inside, negative input of ln. I have this negative 14. So I would say x is not in domain. So if any of the logarithms has a negative input, your answer doesn't work. If they're all are positive, and assuming you've done your work correct, then your answer is correct. So that's the shortcut of, we don't, sure, it's a good idea to check our answer, but really, actually write it here. Really, the question I'm going to ask myself is, will this value get me, have any of my inputs become negative? And if that is the case, I would say no solution. I suppose if I had multiple answers, maybe one of them would work and one of them wouldn't, but usually with logarithms, we'll have only one answer. So any questions about this? Pretty quiet group today, especially considering the domain thing's pretty important. Make sure you have that concept locked down. Okay, just a quiet group today. I'm fine with that. Okay. 2 last questions, and then the rest of class will be review. So, kind of spoiled this one already, saying that, okay, if I have a single log on both sides, they're the same log, then I just can drop them and solve for the base. Same thing with exponentials. If I have, and the base has to be the same like it is here. If I have matching bases, well, that's a really nice case because all I have to do is set the powers equal to 0. Sorry, equal to each other and solve. So how would I solve this equation?
I mean, that's undefined, right? Can't be solved.
Yeah, how did you get there? How do you know that's undefined?
Just kind of intuition, because v minus 1 can't equal v.
Yeah, or you know, I can do one additional step of just subtracting v from both sides. And then I get negative 1 is equal to 0, which is a little bit even easier to solve with your intuition. But yeah, honestly, I don't hate that you were like, well, okay, there's not a whole lot of numbers that if I subtract 1, I will get the number back. So you could even stop here and say no solution. But if you want to, without a doubt, well, just subtract. Get no solution. And with exponentials, I don't necessarily have to check my answer once I get it. Like if I get a real number answer, great, there isn't this domain I have to be concerned about. The domain of an exponential is everything, all real numbers, where the reason I have to go back, I must go back and check my logarithms, is that I can't have a negative inside my logarithm. Okay. Now to solve this, my goal, just like it is with logarithms, is if I'm not able to get to something like this where I can set both powers equal to each other, then I still want to get at least, not at least, at most a single exponential. If I'm able to do that, then I have these nice kind of powers that I can translate and solve from there. If I have 2 separate exponentials, that's not so much of an option. And so I believe I've mentioned, and if I haven't, I don't feel too bad springing this brain breaker on you right now. But if I have, no, I've definitely mentioned this once or twice. If I have 2 exponentials with the same base, different powers, well then, and I'm multiplying them together, well then I just add the 2 powers. So all of that's to say, since I have 2 separate exponentials here, let's make it a single exponential. And since they have the same base, I'm allowed to do so. So I will get x plus 1 plus x minus 1 just gets me 2x. Okay. I kind of already mentioned what the next part of my process is, but does anybody know what I should be doing at this point? Any thoughts?
Would you subtract the 1 from the left side?
Yes. Why are you doing that? Kind of just to give ourselves a big picture situation.
I just wanted to kind of get that x in a sense isolated.
Perfect. Yep. I want to get the exponential by itself. Okay. What's my next step?
Divide both sides by 2.
Perfect. Now, here I have two options. If I have a fancy calculator, or honestly, I think I mentioned that it doesn't have to be that fancy of a calculator. But if I have a calculator that I can use and solve logarithms for, what I can do here is translate them. So if I translate this, I would get 2x is equal to log base 4 of 16. This is something that you can throw in your calculator, or you can use the change of base formula I've mentioned once or twice. Or you can a little bit use your intuition here of, okay, I have 4 to the 2x, but I notice here that 4 is somewhat related to 16. How would I get 16 if I started with a 4? I mean, that's kind of a vague question, but I'll take different answers.
Square it.
Yeah, right. 4 squared is equal to 16. So what I can do here is, since that's the case, instead of dealing with the 16, well, I might leave it there for the notes. I'm going to change my 16 into 4 squared.
X would be equal to 1, right?
Yeah, exactly. And now that I have the matching bases, now I can set the powers equal to each other, and I have a one-step problem to solve. Not a bad idea to check your answer, take this, plug it into the equation, but not required. Assuming you did your steps correctly, there's not going to be a situation where if you only have exponentials, that you will have some weird domain breaking or some undefined solution after you get your solution. Honestly, it's not that hard to check. So if you have the time on the final exam, which you probably will, you have plenty of time to complete the exam. It's a good idea to go ahead and plug in and solve, but not required. That's the difference with exponentials. Exponentials as a domain of everything. Logarithms has a domain of 0 to infinity, not including 0. So parentheses 0 to infinity. Any questions about this? Okay, you might get a question of this speed on the worksheet if you're going to do that. Maybe 1 or 2 questions on MyMathLab, but it's going to be part of the optional assignment, so it's not the end of the world if you don't know how to do it. But I'm not going to put a question like this on the exam. So instead of taking time going through that, it's an involved process. Use substitution, which I believe we've covered in this course. We've definitely covered use substitution in this course. So if you want to go about solving it on your own, great. I'm not going to put on the final, so I think it would be better for everybody to focus on reviewing at this point. So with that being said, stop my recording.